solving quadratics is a really important skill to have under our belts. There are several different ways that you can solve it. So one is to graph. You can do it by hand. You can use your graphics calculator and solve it that way. You can factorize, complete the square or quadratic formula. Okay. What we want to focus on in this video is our factorizing, mainly because it's quick, hopefully, and simple. Obviously, not every single quadratic can be factorized, so we want to be able to suss pretty quickly how to do it. What we're going to do is look at just the skill of factorizing, and then we'll tack on the solving a little bit later on. So you can suss if you're wasting your time or not. These are some of the expressions that we're going to factorize, and then we'll do a selection of solving them as well. We have to add to that equation. So just let you have a quick squiz. If you think some of this is easy, then don't bother watching this video. Okay. So, oops. And then we'll get into some of those ones. All right. So when we want to fully factorize any expression, the first thing that we have to do is check if there are any common factors. That's the very first thing. So it could be a common letter, a common number. Once we have removed any common factors, or we've established that there are none, we look for the type of quadratic that we see. If it's difference of two squares, we factorize like so. If we can recognize perfect squares, it's this. And then we've got the good old just sum and product. And as I said, we'll get to that in a minute if you're thinking, I don't know what that means. So let's go over our first revision, I guess, about common factors. So we look at these expressions, and the first thing you want to do is say, is there a common number that goes into both of these terms? Clearly, it's 8. So we will pull out 8 as a common factor. We then look to see if there is a common letter. And in this case, x appears in both terms. So this is now where depends on how you look at it. You can either divide each term by 8x. I like to think 8x times what gives me 8x squared. So I know that has to be x. Double check, 8x times x, yes, gives me x squared. And 8x times what gives me 24x, that has to be 3. And that's that expression factorized. Okay, you can go up a little bit further. Once again, do each term at a time. 5 is the biggest number that goes into both of those, and then we look at the x's. Now we've got an x squared and x cubed. X squared is the highest one that it can go into both of them, and also we've got y squared, because we've got y squared going into this and y squared going into y to the power of 4. So we've already got the 5, that's there. X squared times what gives me x cubed, that's an x. Y squared, well, it's already there, so I don't pull that out. 5 times what, we're on to the next term here, times 3 gives me the 15. Do I need to put an x? No. If I put an x there, I'd have x squared times x, which gives me x cubed, no good. So I've already got my x squared out here, and I need a y squared times what to give me y to the 4, and that has to be y squared. So that's all done and dusted. We carry on, and we think, yep, that's pretty groovy. And we get to something that looks a little bit like this. Now, notice there is no common factor because x appears here, but this doesn't have an x. These terms both have an a, but these ones don't. But there is something that I notice, and that is that these two terms have a common factor of x, and then these two have a common factor of a. So I'm going to just take a second to see what happens if I pull those out separately. So if I pull x out here, and we look at these two terms, I end up with x squared minus, in fact, I don't even have to pull out x. I could pull out x squared as my common factor, because, just keep on going with that actually, if I pulled out just x, I get x squared minus bx. Now you can see here that there's still a common factor inside the bracket, which tells me I haven't pulled out the highest common factor possible. So always check that you have pulled out the highest common factor. So x squared times x gives me x cubed. X squared times minus b gives me minus bx squared. Now I'm not really sure where this is going. I'm having a look because I had lots of common issues here. So we'll just see if something pans out. What have we got here? We've got a squared is a common factor. A squared here, and lo and behold, when I pull this common factor out, a squared times x gives me ax squared. And if I pull out an x squared from here, now you might be tempted to put the b, plus b, but if I say plus b like that, double check when we're expanding the bracket. A negative times a positive gives me a minus, and I want that to be a plus, which means that should be a minus there. Negative times a negative gives me the positive. And now, lo and behold, look what we've got here. We've got a common factor of x take b and x take b. So I'm going to pull that out as a common factor. So pull out that x take b, and if I pull it out from this term, I'm left with this x squared. So that goes there. And then I pull out this x take b from this term, and I'm left with minus a squared. Okay, so believe it or not, if I was to expand this, I would get this expression. I'll just give that one more shot, because if I now look at this, in order for me to factorize this, if I wasn't looking for a common factor, I would have to expand, and that's going to become quite a disaster. But if we look carefully, you can see here I've got a common factor, right? Not just an x, not just a 2, but a whole common factor of 2x take 3, because that's being times by x plus 5, and this is being times by 2. So I'm going to pull out that whole 2x take 3 as a common factor. Now when I pull it out from this first term here, right, I'm left then with, so that's now gone, I'm left with x plus 5. And when I pull the 2x take 3 out from that term, I'm left with the minus 2. I could put brackets around there, but it doesn't really help. If this had another factor like that was 2x plus 1, I would put that in a bracket because of that minus sign there. We'll look at one of those in a minute. So we've got 2x take 3, and then all we have to do now is tidy up what's in the bracket here. 5 take 2 is 3, and that is fully factorized. So carrying on with that, this is the same sort of thing here, I notice. Remember, we're always asking ourselves, is there a common factor? And again, look carefully, we've got our common factor here of x plus 4. Remembering, x plus 4 squared is x plus 4 times x plus 4. So we'll pull that out as a common factor. Okay, so once I pull one of these x plus 4s out, that's gone. What am I left with? I've still got this x plus 4 here. And now I'm going to pull this x plus 4 out, and what am I left with? I've still got this 3x plus 1. And this is where you have to be really careful, because I can just go, that's minus, but it's actually subtracting this whole thing. So you must put that in a bracket as well. And you'll see how this changes things just a tad. This becomes x plus 4. Now I'm taking 3x, take 1. Or you could look at it as that's technically a minus 1 there, and you're expanding that bracket. Okay, so now when you tidy that up, x take 3x is minus 2x, 4 take 1 is positive 3. Okay, now you could leave it like that. You could also write it as x plus 4 times 3 take 2x if you so desired. Okay, done. That's probably looking at the whole common factor thing. So every time you do this, it has to be just routine. Is there a common factor? Always check. We come to this one. Clearly, there is no common factor. However, if we go back up to our styles here, we can see that it does fit the pattern of difference of two squares. It's something squared minus something else squared. And this always factorizes to be, what's the connection between a squared and a? That's the square root. And what's the connection between b squared and b? Square root. And you just switch the signs around. So let's give that a whirl. And I'm hoping these are familiar to you. So what we can do here is say, well, what's the square root of x squared? Well, that would be x. And what's the square root of 16? 4. So we go take 4 plus 4. And using your brilliant expanding skills, I'm sure you can check that expansion to see that you get this. All good? Carry on. We go to the next one. So feel free to stop the video and do some of these yourself if you remember. But if you need a bit of a nudge, listen along. So once again, what do we have to do here? Common factor. So is there one? What's the biggest number that you can think of that goes into both of these? So 9. I mean, if you went 3, once again, you would have ended up with another factor to pull out from the bracket. So always try for the highest common factor you can. So 9 times 9 gives me 81. I'm left with the x squared, and 9 times 5 is 45. Now, once again, there is no more common factor here, and you sort of think, well, that's as low as I can go. But I'm here to tell you that you can use the whole difference of two squares thing to factorize that further. Because what times itself gives you 9x squared? I hope you're all calling out saying, well, that's 3x. It's 3x times 3x, correct. But now you might be flummoxed going, well, hang on, I don't know, there isn't a square root of 5. A nice square root anyway. And that's correct. So we can write it like this. We go take root 5 plus root 5. And that is fully factorized. So 3x times 3x gives you the 9x squared. 3x times plus root 5 is plus 3 root 5x, but then I get a minus 3 root 5x. So they cancel, and negative root 5 times positive root 5 is minus 5. So that's difference of two squares getting a little bit carried away. And of course, you can carry it away all to the utmost. So once again here, you can see this is another form of something squared minus something else squared. Okay, so is there a common factor? No, it's just simply difference of two squares. And so here we go. I'm going to pop that into the A take B, A plus B mode. So what is the square root of a plus 1 squared? Well, it's x plus 1. And then I'm going to take away the square root of this, which is 3x plus 4. But I'm taking away all of that, so that has to be in the bracket. And then it's exactly the same, but instead of a take there, I'm going to put a plus. So it's x plus 1 plus 3x plus 4. I hope you realize I don't need to put brackets here, because when there's a positive sign, it doesn't have an effect on the signs of the terms in there, but the negative certainly does. So now we tidy up x plus 1, it's taking 3x, take 4, this one becomes x plus 3x is 4x, 1 plus 4 is 5, tidy this up. X take 3 is minus 2x, and 1 take 4 is minus 3. Now technically you're done. That's fully factorized. I'm just going to do one little sneaky thing. See if you can see what I have done when I write this. You think, is this the same? Hopefully you've realized all I have done here is I've taken out a negative 1. So I've pulled minus 1 out as a common factor, because you can see here, if I now multiply this bracket through by negative 1, negative 1 times 2x is indeed minus 2x, and minus 1 times 3 is minus 3. So these are equal. Okay, moving along, we now go to what we call the trinomials here. So we've got 3 terms. Once again, is there a common factor? X, x, this doesn't have an x, so that's no good. So what we have to do now is remind ourselves, go back up to our various ones over here, and this is where we do the sum and product. We're looking for two numbers that times together give you the last term here, but add up together to give you the b value. So I've chosen pretty simple ones, but it's just a routine that we go through all the time. So what I would do here, I'm looking for two numbers that times together give me minus 8, but when I add them I get minus 2. I'm sure you guys can already know what they are, but just in case you don't, and when there's bigger values, I suggest list the factors and always start with 1. 1 goes into 8, then check, does 2. 2 goes in 4 times, does 3, does 4. Now, because 4 is already there, you've got all the factors, it's done. It won't actually take you long if you do that, and you won't miss any ones, because the reason that you can't look and go bang, factorize straight away is you miss some of those factors. So always list in order. And now we go, well, to get the x squared, it has to be x times x. We clearly know it's got to be this one. Let's try the 4 and the 2. And of course, one's got to be positive and one's negative, because when I times them together, I want a minus 8. So is it going to be minus 2 plus 4, or is it going to be 2 take 4? And clearly, it has to be this, because I want a minus 2. This here gives me positive 2. So it's take 4 plus 2, and that is done and dusted. Okay? Hopefully you're still with us. I'm just trying to do this reasonably quickly. Right, another one here, trinomial. We look, and first thing I hope you notice is that all of these are even. So once again, the first thing you always have to do, is there a common factor? And clearly with this one, 2 is a common factor. So 2 times x squared gives me 2x squared. Remember, you're either saying 2 times what, or you're dividing through by 2. That now becomes 3x. Take 10, double check, yes. 2 times 3x gives me 6x, 2 times minus 10 gives me minus 20. Awesome. Okay, we're going to take a few seconds just to see, is it factorizable? Because remember, sometimes it can't be. So we're not going to spend ages trying to factorize something that maybe you can't. We're looking for two numbers that times together give me minus 10, add up to be 3. We list the factors, 1 and 10. Once again, I think you already know. 2 goes in 5 times, 3 doesn't, 4 doesn't, 5, you've got them all, and clearly it's these two that have a difference of 3. Once again, because when I times them together, I want a negative 10. One has to be positive and one has to be negative. So again, do the check. Is it minus 2 plus 5, or is it 5 take 2? Oh, that's the same thing. What am I doing? Silly. So that is it 2 take 5. This one gives me minus 2 plus 3 is 3. 2 take is minus 3. So once again, it's got to be this. So we'll go x take 2, x plus 5. Done. Okay, nearly there. So once we get to this one, I see the 3, and I'm really hoping that there's a factor of 3 that I can pull out, but alas, 3 doesn't go into 16. So the only way that I can get 3x squared is to have 3x times x. So that's actually quite nice that this one's a prime number, because you can only have 3x and x. If we look at this next one, we could, to get the 6x squared, and is there a common factor by the way? No. To get 6x squared, well, you could have 6x times x, but you can also have 3x times 2x. So when we've got ones like this where there's multiple factors, it's a bit of a pain in the butt, and to be honest with you, I would probably go to the calculator or quad formula after I've maybe spent 1 minute trying to factorize, no longer. Anyway, back to number 11. So what are the factors of 12? We've got 1 and 12, 2 and 6. Does 3 go in 4 times? 5, no, 6. It's already there. You've got all the factors. So could I use 12 and 1? Now if I put the 12 here and the 1 here, that's 3 times 12 is 36 and a 1. Well, that's not going to happen. And if I put the 12 here and the 1 there, that's only going to give me 12 and 3. That won't get me the 16. So it doesn't take very long. And you can actually say, well, that one's out of there, ruled it out. What about, oh, I'm looking here, and again, it comes down to your times tables that I'm going, well, I recognize 3 times 6 is 18, and then if I take 2, wow, I get the 16. So 3 times 6, let's pop that there. We want it to be plus 16. So if I put the plus there, that gives me plus 3 lots of 6 is 18x. And then if I go take 2x here, 18, take 2 gives me 16. And negative 2 times positive 6 does indeed give me minus 12. So it's sort of like a trial and error. I mean, you can set up little cross product things if you want, but really, if your expanding skills are up to scratch, you should be able to do this reasonably quickly. All right, this one, as I said, we don't want to take too long. What are the factors of 15? Luckily, it's 1 and 15. 2 doesn't go in, and it's just 3 and 5. So once again, I'm not even going to bother with putting the 15 here, because 6 times 15 is way too big. It's not going to get me the 13. What about if I put 5 and 1? Well, 6 times 5 is 30. Nope, that's not going to work either. What about if I put the 1 here and the 15? So that would give me 6x and 15. 15 and 6 won't get me 13. So you can see it's pretty much this trial and error sort of thing. And 6 3s, if I put the 3 here and the 5 there, that's going to be too much too. 6 3s, oh no, hang on. 6 3s are 18. 18 take 5. Aha. Okay, so we want it to be negative 13, so that has to be minus 18 plus 5. So we're going to say 6x take, and then the plus. So, you know, it wouldn't have taken that long if it hadn't been that to go to the next one. So just, as I said, there are the little systems that you can do and pull out, split the terms and whatever, but I honestly believe if you can just expand nicely, well, you can factorize really well too. So remember, the whole point of factorizing was because we wanted to solve. So you can solve if we change all of these now. So far all of these are expressions. As soon as I put an equal sign here, equals 0, this is why we factorize, because when it's in this form, I can now say if I can make this bracket 0, 0 times anything gives me 0. So I'm solving technically x take 4 equals 0, therefore x must equal 4. Put the minus 4 on the other side. And I'm also solving this one, x plus 2 equals 0. Put the 2 on the other side, clearly x equals minus 2. So those are my two solutions. Pretty simple. Here, beautiful, that would be x equals what take 2 equals 0, it has to be 2. And what plus 5 equals 0, that's x is minus 5. So this is the whole reason why we actually want to factorize, because we can get those solutions really quickly. Okay, no prizes for guessing that this one would be x equals minus 6. Minus 6 plus 6 gives you 0. What about this? Please do not say 2. Remember, what you're actually solving here is 3x take 2 equals 0. So the 2 goes on the other side, and to get rid of the times 3, we divide by 3. So that's going to be 2 over 3. Do that often enough, you'll actually see the trick or the pattern that you can solve. So this one I can say straight away, it's going to be minus 5 on 6, and x is 3. Okay? And just to finish off, if I want to make it a little bit harder, it's not really about harder, it's just challenging. We go, well, we haven't even got a quadratic here. So how do we get it to that form? The first thing we notice is this divide by x. So to get rid of a divide by x, we have to times, and we have to times the whole other side by that. So what we're going to do is x times x plus 8 equals 20. And now we can expand the brackets. We've got x squared plus 8x equals 20. Remember, one of the rules is everything has to be on one side. So we've got x squared plus 8x take 20. Go through the rigmarole. Is there a common factor? No. Is it difference of two squares? Clearly not. So we take a few seconds. What are the factors of 20? So two numbers that times together give you minus 20, but add up to be 8. So list my factors. 1 goes in 20 times, 2 goes in 10, 3, no, 4 goes in 5 times, but there's the winner to get me the 8. So it's x. Remember which one's positive and which one's negative, because when you times them together you want minus 20. So again, if you're not sure, check it. Go minus 2 plus 10, well, that gives you positive 8, which is the winner. Whereas if you had gone like so, you got minus 8, which is not what we want. So it's take 2 plus 10 equals 0. Therefore, x is 2 and x is minus 10. You reverse the sign. And you might go, oh my God, I've had enough. It cannot get any harder because, oh, look at this. But you do one step and we're back to simple ones. So we go to get rid of, we've seen this before, to get rid of our divide by x take 3, we're going to times the other side. And to get rid of a divide by 2x take 7, we're going to multiply the other side. So we're cross multiplying here. So we end up with x plus 4 times x take 3 6 times 2x takes 7. Okay, remind yourself how to expand, but once you've now got this beautiful factorising under control, hopefully we now know, yes, it's x squared, and then we just add these together. So 4 plus minus 3 is 1x, and 4 times minus 3 is minus 12. If you don't like that, follow all the loops. Okay, remember we want everything on one side, so it's x squared, 1 take 12 is minus 11, minus 12 plus 42 is 30. Okay, ask yourself those questions. Is there a common factor? No. Is it difference of two squares? Clearly not. So what are the factors of 30 that add up to 11? 1 goes into 30 times, 2 times 15, 3 and 10. Does 4? No. Does 5? Yep. 6 times, 6 is there, and there's our winner. Now, what are the signs? This time when you times them together, you want it to be plus 20. You can't have them both plus, because when you add them together you want minus 11, not positive 11. So that's a sign to you that they both must be minus. And finish off x equals 5, x equals 6. So hopefully that helps a bit. Obviously come and see me if you want more detail explanation on any one of those. But that was just trying to remind you about your factorising and solving. Go do the worksheet now, please.